Hi everyone. In this video, let's look at text generation using LSTM, except instead of English, let's look at two non-English languages, and obviously the two languages that I can read and write. Now, one would be Hindi, which is the national language of India, and the other Telugu, which is one of the major languages spoken in two states in South India, and that happens to be my mother tongue. So for those of you who understand Hindi, पिछले वीडियो में हमने LSTM के साथ अंग्रेजी की वर्ड्स जनरेट किया था. ओके, अब इस वीडियो में हम हिंदी जनरेट కरेंगे అండ్ తెలుగు వాళ్ళకి ఒక తెలుగు టెక్స్ట్ని మనము LSTMకి ఫీడ్ చేసి తెలుగు టెక్స్ట్ని ప్రింట్ చేద్దాం, ఫోర్కాస్ట్ చేద్దాం. ఓకే, ద ఎంటైర్ లెక్చర్ విల్ బీ ఇన్ ఇంగ్లీష్ జస్ట్ సో everyone can understand. But if you can read and write Hindi and Telugu, my guess is you're probably from Hyderabad. You're welcome. Okay, so let's jump in. Okay, so let's jump and look at the code. And first thing, exactly same as last time, right? I mean, the libraries would be the same. So let's go ahead and read the libraries. And the text for Hindi, I was looking for Hindi text in Project Gutenberg, and believe it or not, it doesn't have any. So if you search for Hindi, you would not get. They have Punjabi, they have Bengali, and they even have Telugu, right? I mean, so that's no records found. In fact, you would find if you go ahead and look at book search and search for Telugu, I hope you'll find something. They may have removed it, but I found a Telugu text called Agnigundam, okay, and which probably means volcano, and it has enough text for me to train this algorithm, okay. And also Hindi, I actually went to a bunch of government sites in Government of India websites and copied and pasted a whole bunch of text. So if the prediction is about Mr. Modi's, one of the yojanas, then maybe we can generate something new and give him some ideas. Okay, so anyway, so I put not much text, but hopefully enough to train this and then start predicting this text. The only thing that you have to think about when you're typing it somewhere, copying and pasting or anything, when you save this file, when you save it as text, select UTF-8, which makes it readable from within Python using the code that we are writing here. Okay, that's the only thing. Otherwise, it doesn't matter. Hindi, English, Russian, whatever, Tamil, Malayalam, whatever language that you can read and write, okay, save it as UTF-8. Next step, let's just go ahead and read this, okay? And again, please watch my previous video where I have spent a bit more time explaining every step, but here we are just reading it. And you see the encoding here, UTF-8, and then I'm printing it just to make sure everything is reading and writing okay. Okay, so I am reading Hindi here. Okay, I mean printing out Hindi here, reading Hindi into Python. So the next step is I'm actually removing all the digits. You see there is a digit called 23 here, 2018. It's optional. If you want to keep, you can, but I'm just removing this, and let's go ahead and remove that. And if I print this again, we should not see any of those numbers. You see here the numbers are gone. So here we have 23 September 2018, and we just have September right here, right? There is no 2018 or 23. So this, you can clean it up. You can even remove English words. This text seems to have some English words, abbreviations. You can remove that, but for now I'm just removing the digits. Okay, and now let's just look at how many characters we have. I mean, in English it's easy, right? I mean, in English you have some quotations, some non-characters like commas and all of those. And if you watched my previous video, you saw that we had 48 total characters that are present in this entire text. But Hindi and most of these, especially Sanskrit-based languages, also Dravidian languages like South Indian languages, the grammar is different. You have a whole bunch of vowels and you have a whole bunch of consonants, and then you mix the vowels with consonants to get even more words or alphabets. So it's not that easy. So here we have 103 characters. And if I open this up, we could clean this up like brackets, parentheses and all of these. We also have English, A, B, C, D, all of those 26 apparently. Well, no Z, but most of those. Now you have A, I, E, I, O, 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 all these vowels, Ka, kha, ga, gha, cha. So you have most of these, and when you add all of these, it comes up to 102. So for now, I'm okay. I'm not cleaning it up, but you can clean it up if you want, okay? Now let's convert our characters into integers, because again, that's what the computers like the best. So if you look at characters to integers, let's look at what in this case is. So A is assigned a value of 36. Okay, so the numbers is what LSTM is working on. And let's do exactly the reverse so we can convert it back when we are predicting or when we are forecasting or when we are typing our text later on. Okay, so now let's go ahead and summarize this. Of course, our number of characters and vocabulary would be so different from last time. We have 103 total vocabulary, meaning total number of characters. In the last video, we had 48 of these. And the total characters in the text, like corpus length, is only 34,600. So the entire text is only 34,600 characters. So the prediction may not be that accurate, but again, I did not find any text files with Hindi. So I hope one of you guys can spend some time in putting together a very nice large text file that everyone can use for natural language processing. Okay. In fact, when you are starting to predicting the words at word level prediction, it even helps to actually have these all captured at a word level, not just at the character level. Okay, so putting this together can really help, like a document, a long document with a lot of text. Okay, so down here we are converting our text into sentences again. The example we are doing here is you have this long text, right? I mean, here, let's see. So here you have like, okay, Ayushman Bharat Yojana. Okay, Bharat Sarkar की एक प्रतिवादी योजना है. Okay, प्रतिवादी प्रस्तावित योजना है. Sorry for I didn't read Hindi in 25 years, but anyway, I can always brush it up. So we can actually start a sequence of 60. So start with this quotations and go up to 60. Let's say the 60 ends at here. Okay, yoja. And then the 61th alphabet would be na. Right? I mean, after yoja comes na. And then I'm moving 5 steps, which means 1, 2, 3, 4, 5. So I start at na. Na Bharat Yojana, and then all the way to the next letter. So I'm moving in steps of 5. If you watched my previous video, you probably know what I'm talking about. So throughout the text, I start from 0 here and then go 60 and create a sentence, and then move by 5, create another sentence, move by 5, create another sentence, and I'm creating capturing all of that into something called sentences. And then the next character is nothing but the character that comes after that. So when I train an LSTM, okay, जब हम LSTM को train करते हैं, the X values that goes into that, okay, into the training are the sentences, okay, and the Y value would be what word comes after that. What letter comes after that sentence. So when we run this, hopefully this should make some sense to you. And how many sentences did we actually generate? 6,908. If I actually make my step size to be like only 1, then I'll have a lot more of these sentences. For example, if I go back and do a step size of 1, now I'm moving it every 1, right? So now I have 34,540 more data to train, which is probably what I should do here, but that's okay. Let's keep it at 5 because I want to train this in a decent time. So let's go ahead and do that. So we have 6,908. Now, if you look at sentences, let's go to sentences. These are the sentences it created. Okay. And then let's look at next characters. These are the characters that come after that. So if you just look at number 2, Bharat Yojana, Bharat Sarkar ki ek प्रस्तावित योजना है, इस योजना, and then after that, okay, number 2, right, comes ka. Whatever comes after that, okay? But you can actually see here, is yojana ko is the one that comes next, okay? And so on. So we are moving it by 5 and actually tagging in what comes next. This is how we are training it, okay? I hope this is clear, okay? So again, let's pick one more. Let's pick number 7, okay? Yojana ko log Modi ke, I don't know what that is, ke naam, okay? Ke naam, what comes after that? Sa. Ke naam sa. Okay, is that really the case? Ke naam se bhi. Okay, so sa comes next, and then it adds a. So this is how it creates characters. Please understand this. Once you get this, everything else is simple. Okay, so let's go ahead and close this. And now let us convert this into vectors, because you cannot just feed a bunch of text. You have to actually convert them into vectors. What this is basically saying is my corpus, my length is 60, right? My sequence length is 60. So I'm generating 60 character length sentences. So that's where the 60 comes in. And 6908 is 6908 sentences. So 6908 sentences, at each position within the 60, I have 103 choices. What are those choices? The choices are either, if I can open, where is that? The choices are characters, right there, sorry. The choices are all of these. So it can be it can be I, it can be E, it can be English alphabets, it can be any of these. So we have 103 of those. So this is what goes into our LSTM. And then the prediction, the Y values, we have 6908 and we have same 103 available right there. Okay, again, I covered this in the last tutorial, so let me just go ahead and define our LSTM network here. Again, I'm using sequential method, and I only have like two things. One is output and one is LSTM layer with 128 units here. You can add some hidden LSTMs, like I am giving you, this is commented out, but you can see I have LSTM with 128 and LSTM with 128 that's hidden. Make sure you return the sequences, otherwise this LSTM doesn't have any input, in terms of sequences. So I'm leaving this code for you to explore. And the next, we just need to train it. We can just go ahead and train this, which I just did before this video, so I don't waste your time. So let's come down and go ahead and predict it. Okay, so this is the prediction part. So what does prediction mean? So we are going to give it a sentence as an input. Okay, just like time series, we are going to give a sentence as an input, and then now we are asking it to predict 60, 100, 200, whatever. Yeah, we can just do 400 for now. Okay, predict the next 400 letters after this initial 60. So we need some seed. So for that, let's actually get a random sentence from our from our Hindi text, and then let it predict. Now, what does it predict? Because we are using softmax, it actually predicts probabilities of each of these 103 characters. For example, if you have sa, what is the probability that the next one is a, which makes it say, okay, in Hindi, right? And if that probability is high, that's what we are going to pick. Again, please think about this. So we are converting this, using this, we are actually picking the maximum probability. That's all it is. This is basically a softmax. And I already saved it with this name. So let's go ahead and load that model. And also load the, obviously load the model. Here, it's just a name. And here we are just picking a random number. So my start index is 6,318. All it's doing is it's looking at how many do I have, 6,900. Just go ahead and pick a random number within 6,908. Okay. And then it's telling me that the random number is, if I can find it again, what did we say? Start index 6,318. So it goes in at that position and reads the text. And let's generate that text. And why are we doing this? This is our seed that gets, that goes into the prediction, and then now it starts the forecasting after that. Okay. So if you just look at generated, this is the seed. Okay. Tahsil ke antargat gaon. Okay, so this is where we are actually starting, and Nirthan Dhaka, that's the end. So believe me, this is 60 characters. Okay, all those 60 now go into the prediction part, and now we are going to forecast the next 400 characters. That's all we are doing. So let's go ahead and do that onto the screen. And again, this is basic code, so I'm not explaining every little part of this code. All we're doing is just printing it on the screen. So, initially, this is all just being generated. And these are real generated words. So some of them may make sense, some of them may not make sense. So let's go ahead and look at this. Man, word. Har is a word, every, right? Or, and. Grameen, village. What is this? Akhyavadhan, I don't know if that's a word, sounds like a word, ke saath, mein, rupaye, rupee, awa, sanak, okay? Say, viksha, ke. That's pretty good, actually. I'm very surprised, with this result. Now that you watch this entire thing, let's do exactly the same, except in this case, let's do it for Telugu. Okay, so let's go ahead and just print it. So I am going to run this code all the way from the top. Let's remove all the variables, so I don't want it to be confused with Hindi. Although if you're from Hyderabad, you mix Telugu and Hindi all the time. So, and some Urdu maybe. Unfortunately, I do not. Just a second before I do this. Are we doing something? Just a second. Sorry about this. Unfortunately, I cannot read Urdu, but Urdu is such a poetic language. I absolutely love it. I love Urdu shairi, but like I said, I cannot read it, so I can generate, but I wouldn't know what it's doing. Okay, so let's do exactly the same as what we have done before. We are reading a bunch of text. I'm not going to train it because I have already trained it. So let's go ahead and load the pre-trained model right from here, and let's go ahead and print it out on the screen just like we have done before. Okay, so now it says model is not defined. I thought oh sorry, I should actually run these lines right there because it doesn't know what this model is. And now let's come down and start this process again. Okay, so there you go. So it's now predicting the actual. So there is the seed up there. This is the seed part. Okay, now from here it's all just prediction. So it says ani, adrau is not anything. Amma, which means mom. Okay, it's doing this. Pedliki, ado akkada, kardautunnadu. Yiddani. I mean, some of these are not real words, but here ante, vadiki, ఉద్యోగము అని ఉండాల్సింది probably. Okay, చూసిన హాలని. So I mean, you can see how it's actually making some sense in here. Mari monnanni, okay, astamantu dananga. So some of these make some sense, some of these don't make much of a sense, but again, I bet if you actually provide it a lot more text and use a much deeper model like LSTM 128 and 128 here, and you drop out some of these to kind of regularize this, it should do a much better job. But this is not bad either. So my goal one day is to train an LSTM or a transformer network. We'll have to see. I'm still trying to train myself on transformer network on word level tokens, meaning not just letters but words, and train it a whole bunch of text, meaningful text. For those of you who understand Telugu, like Sri Sri Gari Kavitvam, for example, or Hindi, Kabir, ya Surdas, one of these texts, and let it write its own text. That would be amazing. Let it write its own short stories or poetry. So this would be amazing. So anyway, I hope you found this to be useful. I apologize if you guys don't speak Hindi or Telugu or understand this, but at least it gives you an idea of how to get started. Okay, the key lies in just saving it in a text, or the key lies in reading the data into Python. I preferred text Unicode 8, but try experimenting with PDF. It can be a bit challenging. I tried PDF with non-English. It's not that easy. This is the easiest way. So thank you very much. And in the next tutorial, let's learn something new. And please do not forget to subscribe. Thank you very much.